Welcome to Cambridge Chemistry with Sarwat Ahmed. Be sure to like the video and subscribe it. Really helps the channel to grow. Today I will discuss some important tips of paper 3. So when we are dealing with chemistry practical, titration is very common question that will be asked. Before you start conducting experiment, uh, read the question very carefully. Then you should follow some cleaning process before starting the experiment. For example, wash the burette with distilled water. This is very important to follow this step. Wash the burette with distilled water and then rinse with a little of hydrochloric acid. Once second, you must follow the that the burette has been washed and rinsed out the acid solution. Fill it nearly to the top, clamp and burette carefully and run a little acid into the beaker until the tip becomes full. Fill the burette with the hydrochloric acid solution and ensure the tip is full, because the solution which you are taking is the hydrochloric acid. For example, the pipette can be cleaned. This is very important to follow. The pipette can be cleaned in a similar way to the burette, remembering to finish by washing it out with a little of the alkali solution, because a pipette safety filler is used to draw a measured volume of sodium hydroxide solution from the burette beaker into the pipette. Rinse the conical flask. This is first apparatus you need to wash, and second apparatus pipette very important to need to wash, and third apparatus is conical flask. Basically these three apparatus are commonly used in the titration. Now rinse the conical flask with some distilled water. Deionized water means distilled water. In this case it does not matter if there is some water left in the flask after rinsing it, because it does not affect the mole of the reactant. Now pipette exactly 25 centimeter cube of 0.100 mole per dm cube solution of sodium hydroxide solution into a conical flask, or whatever the solution you are instructed in the question paper, into a conical flask. Now add 2 or 3 drops of acid base indicator. Indicator always sometimes it is given in the question and sometimes in the question. So add 2 or 3 drops of acid base indicator. Now read the burette and record the reading in the middle row of the table like the one below. Now before starting the experiment, before taking the reading, place the conical flask. This is another instruction you must follow during performing the experiment, that place the conical flask below the burette on a white tile. Run acid into the flask fairly quickly, shaking it all the time as soon as the color of the indicator changes. Close the tap and note the final burette reading. Record these results in your table. And an important things to remember with the titration is you to get a lot of marks from creating your tables. So what you would usually get is you will get information about the solution that we have been given, as well as what indicator, and then your instructions. So in this case, first we did a dilution of one of our solution 25 centimeter cube into a 250 centimeter cube volumetric flask to dilute it, and then we used that solution of the acid to titrate with with our burette and 25 of our other solution in our flask, and first thing was perform a rough titration. The first titration is a rough titration to give you an idea of the volume you need to add exactly neutralize this acid. It is quite likely that you added a slight excess of acid as you were doing the titration quickly. Now repeat steps 2 to 7, but this time run in the acid quickly until you reach about 1 centimeter cube less than the volume you added in the rough titration. And you know that in the rough titration there is a little space given for note down the rough titration, and this is quite a small space. Anything should you do in chemistry must have tables, so we draw our tables with ruler like this. Final burette reading you must write down in first column is final burette reading. This is very important to draw the table like this, to draw with the scale, always draw with the scale. So final burette reading, and write down the centimeter unit of the volume. This is very important too, and this is for initial burette reading, and along with initial burette reading write down the symbol as well, centimeter cube, and then the volume of the solution used which you are taking in burette. Volume of acid or whatever acid or potassium manganate or any oxidizing agent or any solution which is given in the question is volume of acid used. For example, volume of acid used, and write down the symbol as well. So when you fill up your burette, always starts at 0, and we use 2 decimal places. We use 2 decimal, this is sorry, and initial reading should be in the middle, and always write down in 2 decimal places for a reading always. So it is 0.00, and final volume reading after performing the experiment, like it is quite likely that you added a slight excess of acid, you were doing the titration quickly. Now repeat steps 2 to 7, but this time runs in the acid quickly until you reach about 1 centimeter cube less than the volume you added in the rough titration. Now let's say this is 25.60, and the volume of acid, subtract the initial volume from the final burette reading, and we get volume of acid used, that is 25.60. Now there is the rough titer. Answer is like this: 25.50 is written in your paper. According to your paper, it is written like that. The rough titer is centimeter cube, so write on the rough titer over here. Now after doing this step, to ensure that you have a reliable volume of alkali, you should repeat the whole titration again until you get two readings that agree within 0.10 centimeter cube. So the difference between two concordant reading should be 0.1 centimeter cube. So you need to draw up your tables like this: final burette reading, initial burette reading, and volume of HCl uh, used like you have drawn for rough titration earlier. So similar table is drawn afterwards, and we are going to have initial volume, final volume, and volume use. So titration we are doing accurate. So we write initial volume in the middle of the column and then the final volume on the topmost column. So you are going to do as many titration as it's going to take to get our accurate result. For example, if we have initial reading is 0.0 and the final reading would be 25.30, and volume of HCl used by subtracting initial reading from the final burette reading, and this will be 25.20. Similarly, second reading should be like the initial reading. If initial reading is 10.00, the final reading is 35.40, and by subtracting it we get volume of HCl used is 25.40. So take another reading like initial reading we have 6.10, final reading 31.20, and the volume of HCl used is 25.10. Now we have two readings which are concordant, or which has difference nearly equal to 0.10, that is 25.20, and these are the best titration results. There is another column always along with these results. So this is the best titration. Best titration result. So no need to take another reading, because we have two concordant reading whose difference is 0.10. Now next points, how many moles of sodium hydroxide for next step of the titration is to calculate average reading. Like show your calculation: 25.20 plus 25.10 divided by 2. So in this way we get the average reading, that is equal to 25.15 centimeter cube. So the most frequently asking questions are in the exam is how many moles of sodium hydroxide are present in 25 centimeter cube. So in this question you are going to find out the concentration of acid. So first the question is how many moles of sodium hydroxide were present in 25 centimeter cube of the solution. So uh, in this question the mole of sodium hydroxide were required. So we know that the concentration of sodium hydroxide is 25 centimeter cube of 0.100 mole per dm cube of sodium hydroxide. So don't use this volume of the acid. So the concentration we know that is 0.100 mole dm cube inverse 1. Volume is 0.0250 because 25 centimeter cube of volume is used in the conical flask. So calculate the number of mole is equal to concentration into volume, that is 0.100 into 0.0250. The answer is the answer is 2.50 into 10 raised per 2 minus 3 mole. So how many moles of HCl were present in the volume of the acid you used to neutralize the sodium hydroxide solution? We know the chemical equation: sodium hydroxide plus HCl to form sodium chloride plus water. So the mole ratio is 1:1. We have moles of sodium hydroxide 2.50 into 10 raised per 2 minus 3. So the ratio x cross multiply, we have the mole of HCl is equal to 2.50 into 10 raised per 2 minus 3. So this is the mole of HCl. So what was the exact concentration of hydrochloric acid in the mole per dm cube? We have moles of hydrochloric acid. We know the formula of concentration is equal to mole over volume. So we have mole is 2.50 into 10 raised per 2 minus 3, while the volume is 25.15 centimeter cube. So this is 25 25.15 divided by 1000 is equal to 0. So we know that 25.15 divided by 1000, which is equal to, because volume is in centimeter cube and we have to convert into decimeter cube, so this is 0.02515. So this is 0.02515. The answer is 0.50 divided by 0.02515. The answer is equal to 0.09940 mole dm inverse cube. So the most commonly asked question, that why was the conical flask placed in a piece of white tiles? To make the color change visible. Why were the pipette and burette washed with the solution they were going to contain? To prevent dilution of the chemicals. They are going to contain. Why was the conical flask not washed with the alkali solution it was going to contain? So to not add extra moles of alkali. So explain why it does not matter if there is water already in the flask, as the water will not change the number of moles of alkalis. Explain why a conical flask was used and not a beaker to prevent from spillage. You should know these points, very important, and these questions are frequently asked in the examination paper, so you should be carefully and you should keep it in mind, these questions, before while doing the experiment. So this is the introductory video of the titration. So in next video I will discuss the uh, paper question paper from the past papers, paper 3.